What are critical numbers? Yes, so those are the places where we might have maxes or mins. We find them by when the derivative is 0 or undefined. Yeah, so those are the two places where it could happen. On this one, it's just a polynomial, so if we do our derivative, we get 3x squared plus 2x minus 8. This is never undefined because it's not a fraction, so we just need to know when it's 0. Check, can I take out a greatest common factor? No, so then we need to slip and slide. So factor, multiply negative 24 and add to positive 2 would be positive 6, negative 4. Divide our 3 back. So if we set those equal to 0, we get negative 2 and 4/3. Those are the critical numbers. So that means those are the places where we could have a maximum or minimum happen on our graph. All right, are we okay with that? Second question. So still in that section, when we found critical numbers, then we started finding absolute maxes and mins. So it starts off the same way. We have to find our critical numbers. To find our critical numbers, we have to do our derivative. So my function, sorry, that's typed really close together, x minus 4 to the 2/3 power. So the derivative, exponent comes down, inside stays the same. Subtract 1 from the power. So 2/3 minus 1, 1/3. Chain rule, derivative of the inside is just 1. So what this means, what's a negative 1/3 power do? So I have the cube root of x minus 4 on the bottom. What if it were x minus 4 to the negative 2/3? How would we show that? Good. All right, so critical numbers, anywhere this is 0, if I set it equal to 0, I multiply over the bottom and I get 2 equals 0. Does that happen? No. Does that mean we don't have a critical number?
No, it's undefined.
Yes, we have to look at undefined. If it's a fraction, we know right now the bottom can't be 0, so that means x can't be 4. So x equals 4 is my critical number, or critical point. All right, so basically set it equal to 0 and then also check if it's a fraction, set the denominator equal to 0. That's your other critical point. Now I want my absolute max and min. So we have to check both endpoints, 3 and 6, and any critical numbers between them. So if I had also gotten like 0 as a critical number, I wouldn't need to check that one because it's not between 3 and 6. Then we put these back in. Okay, let's see if I gave you nice enough ones that we can do it without a calculator. If I put in 3 minus 4 is negative 1 to the 2/3. So that means the cube root of negative 1 squared. So negative 1 squared is 1, cube root of 1 is 1. If I put in 4, we have the cube root, 4 minus 4 is 0 squared. So we get 0. If I put in a 6, we get cube root 6 minus 4 is 2 squared. I don't know what that is, but I'm just going to leave it as the cube root of 4. Okay. Can you tell me what the smallest number is, the smallest y value? 0. So this is my min. Can you tell me what the biggest number is? Cube root of 4, so that's my max. Remember, if they come out to equal the same y value, you could have 2 absolute mins if they were equal to the same thing, or 2 absolute maxes. All right, so we have a finding critical points only, and then we have an absolute max and min. So critical points and endpoints you have to test. Are we okay there? That's the stuff from the first section. Second section, we were doing mean value theorem and Rolle's theorem, which is what you guys are practicing on your handout. So really, the big thing here is knowing our criteria. The first two criteria are the same. We always have to have what?
Continuous and,
Yeah, continuous and differentiable. This one is just a polynomial. So it's continuous on our interval. By the same reasoning, we know polynomials are always differentiable. The actual theorem only requires to be differentiable on the open interval. I'm not super picky here on how much you give me. If you just wrote, that's a polynomial, so continuous and differentiable, I would take that. I just need to know that you're thinking about those things. We don't have any breaks in the graph. Polynomials, their derivatives always exist. All right, this is Rolle's theorem. Rolle's theorem has a third criteria. What is it? The endpoints have to be the same. So if I put in a 1, or sorry, negative 1, I'll just write this in function notation. So the opposite of negative 1 squared, 2 times negative 1 minus 1. So negative 4. Put in a 3. Minus 1 is negative 4. So those are the same. So we met our 3 criteria. Then what does Rolle's theorem tell us? There's a place where the derivative is 0. Isn't that kind of the same thing as the mean value theorem? Mean value theorem says somewhere the derivative is equal to the slope of the endpoints. If these end at the same thing, the slope between them is 0. So we just have to set our derivative equal to 0. And solve. So x is 1. Is 1 in our interval?
Yes.
Yes. So that's my value. So we found the number that worked. So there's a Rolle's theorem question. 3 criteria, derivative equal to 0. Mean value theorem is our more generic one. We only have 2 criteria. So if I ask you to verify the mean value theorem, what criteria do we have to say? So you can list them out as 1 and 2 and tell me that, or if you just want to say it's a polynomial, so I know it's continuous and differentiable, that is perfectly okay with me. Ooh, I failed to give us an interval on this one, didn't I?
This is what happens when I'm making up problems.
Let's say. On the interval, negative 2 to 2. All right. Then, what do we have to do? Oh, wait. I may not want that in. Yeah, I do. Okay. What do we do next? Find the slope. So if I put in negative 2, okay, negative 2 cubed is negative 8. The opposite of negative 8 is 8. Negative 2 squared is 4 minus 3. So we get 9. If I put in 2, I get negative 8 plus 4 minus 3, so negative 7. So on both mean value theorem and roll theorem, you have to plug in the numbers to get your endpoints. On rolls, they are the same. Here, we have to do our slope between them. So y2 minus y1 over x2 minus x1. And I get negative 4. Now what do we do? Yes, so we do our derivative. Okay, minus 3x squared plus 2x. And I'm setting that equal to negative 4. I like my x squared to be positive, so I'll move everything over. So I get 3x squared minus 2x minus 4. This slip and slide. Does this factor nicely? No, that's the danger of me making up problems, right? So what would I do if it doesn't factor nicely? Quadratic formula. So the opposite of b is 1 minus the square root of b squared minus 4ac all over 2a. There might be one on your homework that requires quadratic. I'll probably be a little bit nicer on quiz. Make sure they work out reasonably well. So 52 you could break into 4 and 13. So I get 1 plus and minus the square root of 13 over 6. And we are looking between 1 and, or negative 2 and positive 2, and both of those are. So those would be my values. All right. Everybody clear what I expect? What's on this quiz? So now you have the rest of the hour to work on homework. Take this when you're ready. I